Of course, there are three logical operators. This is we call it as logical and this is logical or, this is logical not, right? So double and two ampersand symbols has to be given, two and symbols, two or symbols, and one not symbol. So we'll see what are these symbols, how this can be worked. Anyway, it's also binary operators. All these, these two are binary operators, and of course it's a unary. So I'll let you know what it is. Okay. First, it operates on the values which are either true or false. Okay, it operates on either true or false based on this. So we'll get four possibilities, right? So like both are true, one is true, one is false, one is false, one is true, and both are false. So now if I say logical and means if both the values are true, then only true, otherwise it is false. If any one is false, so the resultant will be false. So what about logical or? If both are false, then only false, right? If any one is true, I can write it as true. What about not? If there is true, it will become false. If there is a false, it will become true. Let us suppose this is something like A, this is something like B. So not of A if I write, so here true, it only operates on one operand, right? So it will become false. True means false, false means true, false means true. So if I operate on B, not on B, it is true, then it is will be false. Here it is false means true. So this one, so true means false, false means true. So like this we'll get. So I think this basic we need to have before going to this and logical and operators. Okay. So how this can be done, like in our C programming in compilation. So we'll write some statement where both the values are true, means both the values are non-zero. Okay, true in the sense if you give both the values are non-zero, any value which is non-zero will be taken as true. So any value which is 0 will be taken as false, right? So like this, if I take two non-zero values, then it will be true. Okay, like this we'll get. Okay, but see, if we give the values, all non-zero can be taken as true and 0 is a false. But when a computer wants to return the output, okay, when it wants to return the output as 0, when it wants to return false, it will provide 0. When it wants to return true, it gives 1. Okay, remember this point. So when we give non-zero, it is true. When compiler wants to return true, it returns 1. Okay, yeah, we'll see with examples. I have taken a simple program where it can find the largest of 3 numbers. I have given 3 numbers. Of course, assume that three numbers are different. Okay, something that those where there is no common value for these 3. Okay, I'll take A equals 10, something like this. B equals 8, C equals something like I'll take 7. Okay, yeah, if I give like this, I think we know that 10 is the largest one. How it can be get? So if A is greater than B, it is checking. Anyway, greater than, it is checking what is this value. 10 is greater than 8, it is true, right? So B is greater, A is greater than C, 10 is greater than 7 is true. Of course, remember one more point, we are assuming it as true, but the compiler takes true means it's something non-zero value. Here it is 1 and here also 1. So 1 and 1 or true and true. Of course, true means 1, right? Or non-zero, any value. So 1, right? So this if condition value is 1. So this is what if 1 means true, right? If any non-zero also true, right? If any non-zero including 1, right? So if will be executed. If you get 0 here, else will be executed, right? So like this it will happen. Here you can see 10 is greater than 8, 10 is greater than 7. So percentile D is greater, which is your 10 is greater, it will print directly. Okay, that's it. So anyway, let us take another value here. Here I'll take 5. Let us suppose. So 5 is greater than 8. Is it true? False, right? So it is false. False and 5 is greater than 7. Again false, right? False and false. The resultant will be false, right? Which is 0 and 0, which is 0. So if of 0 is false, so it will come here, else part. Now 8 is greater than 7. Yes, true. True means 1. So 1 means, so B is greater, 8 is greater, right? So 5, 8, 7, which is the highest? 8. Okay, take another constraint. Here I'll take 15. So 5, 8, 15, you have to get 15. You can see 5 is greater than 8, false. 5 is greater than 15, of course false. Here it comes, 8 is greater than 15, false. So here else part, which is 15, is your answer. One more interesting part, okay, that is we need to learn actually. So let us suppose here I have taken something value. Let me take here again I'll take a equals to 10. 10 is greater than 8. Yes, true. Okay, yeah, remember this part. If this is true, then only this can be taken. There is a very interesting point here. 10 is greater than 8, then it is true, then it will check this one, otherwise directly goes out of if condition. Okay, let me take here something like 5. See, 5 is greater than 8. 5 is greater than 8, false. So if it is false means 0, right? Then it won't take this one. Remember this point clearly. Anyway, I explained to get the basic knowledge in the previous, but actual happens is this one. So if this value is false, directly comes out, it won't take this one, it won't be executed. You can see 5 is greater than 8, directly comes to the else part. Okay, so why like this happens? This is a very interesting logic. If you take in the truth table, once again I'll go to the truth table, this one, if first one is true, then you can see there is a chance of getting true. Okay, if first one is true, might be if it is false, you will get. But if first one is false, directly the answer is false, you can see. So that means if the first value is false, so definitely you will get the answer as 0, right? If it is false. So that's why, so this is, we call it as lazy execution actually. So that's why if it is false, where is the need to execute this one? Why? Because even if it is whatever it may be, if it is true or false, the result will be false. So that's why it won't be executed. So then it comes here. So when you write two operations in logical AND, this is a very most interesting thing. Anyway, I'll explain clearly this one with another example. Okay, so for this one you can see it will check and like this it will happen. Okay, we'll see some interesting program. Yeah, let me consider this example, this program. So x equals 1, y equals 0, z equals to 5. What is a equals to y double and z plus plus? What is y? 0. 0 double and, I told you 0 means false, right? 0 means false. False double and something. So it's always false. That's why this is the part will not be executed. Okay, this part will not be executed. So z value will be as it is. It won't be changed to 5. Okay, even if you take plus plus z also. Okay, I'll take anyway plus plus z. Let me see. So z value is 5 only. You can see. You observe what is z value if I ask you. Yeah, you can see the output, that is 5, right? So now what I'll do is I'll change y value as 1. So I'll change y value as 1. Now the thing you can see, 1 in the sense true. True means true and something. We cannot say whether it is entire thing is true or false. True and true is true, true and false is false. So now there is a need of plus plus z. That's why it will take z value. So z value will become 6, non-zero. So non-zero and non-zero, which is true. A value is true and it is asking z. What is z will be? Now it is 6, you can see. So this is a very interesting point that you can observe, especially in logical AND as well as logical OR also. Okay, same thing, like let me take logical OR. Anyone, right? Either of this condition or that condition, right? Now if I take this one in logical OR, so there is a constraint that if first one is true, irrespective of the second one, it always will become true, right? So it is reverse. If y equals to 1 means 1 or something is always 1. So that's why z value will never change. So that's why this value will become 5. You can see it is 5 only, right? But whenever I keep it as 0, now you can see 0 or something, we cannot say 0 or 1 is 1, 0 or 0 is 0. So that's why now this will be executed. Now the answer of Z will be 6. So this is 6. Okay, so like this it will be. This is a very interesting point. And now one more thing. Okay, what I'll write here is X double and Y or plus plus Z. Okay, so like this I'll consider. Okay, X double and what is X value? 1, right? X value 1. Then okay, anyway I'll ask like what is A value. Okay, the resultant I want actual. So now X equals 1, 1 and something I cannot say. So that's why 1 and this has to be executed, right? Y. What is Y? 0. So 1 and 0 is 0. So X and Y is 0. 0 or something. We cannot say exactly, right? So we cannot say exactly. Plus plus Z, which is 6. So that's why, okay, I'll write here what are the values. You'll have 1 double and 0. Okay, slash. Then Z value anyway will be 6, right? So anyway, that afterwards we have to check it out. 1 double and 0, which will become 0, right? Now the 0 or something, we cannot say exactly. 0 or 1 is 1, 0 or 0 is 0. So that's why now this will be executed. 0 or 6, right? Which is non-zero means which is equals to again 1, right? So false or true is true. So A value will be now executed. A value will be 1. And anyway, for your clarity, I'll print Z also. Okay, we'll see A value is 1, Z value is 6. You can see the output now. Yeah, 1 comma 6, right? So this is what an interesting point we can observe in logical and logical or operator. And one more thing, we can check it out. I'll keep here OR, and here I'll keep AND. Now in this case, remember this point. If you give OR and AND, okay, you thought of first I have to do X or Y. But remember, if I have logical OR and logical AND, the first priority will be given to AND only. So that means first you have to complete this one. Then only you have to go for OR condition. Remember this point carefully. So because as per the priority I'll show you here what is the priority rules. Okay, operator precedence rules we call them as. Logical AND is higher prior compared to the logical OR. So like this we need to execute. And still you want it clearly, I have one more program you can see here. So I equals 0, J equals 0, I double and J equals to I plus 10. See, when this J equals to I plus 10 will be executed whenever I value is 1. Why? Because 1 and something is we have to have, but 0 and something is always 0. That's why it won't be executed. For this case I equals 0. So 0 and something means J value will not be changed, right? So J has to be printed as 0. You can check it out. Of course you can write int main there. When you write int main, you have to write here as return 0. I have written void main, then nothing is required at the end to return. So if I execute, you can see 0 is our answer. So why? Because here this part is not executing. So let us suppose if I give other than 0, I'll give something like 1 or whatever it may be. Non-zero I can keep something like 15 or whatever, or 158, something non-zero. So that means non-zero and this has to be executed. So what is I value? 158 plus 10, which is 168. J value should be 168. You can see, yeah, 168. So like this it will execute. These are some interesting and hidden things which we have in logical and logical or operator. I think you can guess the output of this one. So this is 1, this is AND 0 anyway, AND is the first priority. 1 and 0 is 0 or something which is required. So Z value will be definitely incremented. So Z is 6. Option A is the correct answer. So this is the operator precedence table where the priority, if you take two operators, which is on the top will be the first priority. If I take multiplication and plus, multiplication is on top, that's why this is higher priority compared to plus. If both are in same, let us suppose multiplication and division, if both are in same line means you have to take this associativity, left to right, which comes in the left, multiplication. In your question, with this operator, which comes first, that will be the highest priority. So anyway, I'll make one video regarding this, about this operator precedence. And in our question, and or, you can see which is on the top, and compared with all. So always you have to do and operator first. Okay, so like this we have. Of course, this is a one more question, try to get the answer if you are able to. Anyway, I'll explain this one in afterwards in